Good morning, students. Today we will be starting with Unit 4. We have completed Unit 3 in our last lecture. Today we will start with Unit 4. In our previous 3 units, we discussed the lower layers of OSI model, namely physical layer, data link layer, network layer. In the last unit, we discussed network layer in detail. Now in the 4th unit, we have to discuss other upper 4 layers, namely transport layer, session layer, presentation layer, and application layer. These are the layers we will be discussing in this unit. Today in this lecture we will be starting with the transport layer. We have to now discuss transport layer in detail, that what are the responsibilities and duties which transport layer do. In OSI model, transport layer is very important layer. It is the layer which connects the lower layers of the OSI model with the upper layers of OSI model. As you know, the topmost layer is the application layer in the OSI model. This application layer consists of the applications which actually communicate with your computers. So you communicate with any application unaware of the things what are happening in the lower layer, namely network layer, data layer. The user doesn't know how actually packets are transferring, how the connections are made. So all these abstractions are done with the help of transport layer. Transport layer is the most important layer in our OSI model. Now let's start with this. I made these notes for you. I'll be sharing this PDF. We'll be starting with the duties of transport layer. Okay, what are the duties which the responsibilities transport layer perform? First is end-to-end delivery, that is from one machine to another machine, irrespective whether the machines are in the same network or different network. Then addressing, reliable delivery, flow control, and multiplexing. These are the basically main 5 responsibilities of transport layer, which we'll be discussing one by one in detail. Coming to the first responsibility, that is end-to-end delivery. Yes. What do I mean by end-to-end delivery is that the network layer is also concerned with the node-to-node delivery, end-to-end delivery. If you remember, while we were discussing network layer, if you were using only data link layer, to the data link layer was able to send packets if the two computers are present in the same network. But when one sender is in one network, one LAN, and the other receiver is in a different network, be it a different LAN, you use network layer, because network layer uses IP address to uniquely identify the PCs throughout the network. Right? Now here what we will be doing is, network layer sees only end-to-end delivery, that if computer A sends a packet to computer B, the packet is sent, but it is not concerned on which port of B the packet is to be sent. If you remember in the first unit when we discussed OSI model, transport layer is responsible from process to process delivery, that is complete end to end. If it is a port 56, port 70, HTTP, FTP, these are the various applications running on the destination, so it delivers the packet from one port to another. Right? This was our end-to-end delivery. Next is addressing. Addressing, what do I mean by addressing is that in addressing you need a different address attached. अभी तक हमने IP addressing attach की थी with the packet, but for a specific application you also address service port addressing as discussed earlier in the OSI model. For example, if you can see in this diagram, what we are doing is, here are various applications running. These are your physical data link layer, network layer, transport layer. Transport to transport layer is known as peer-to-peer communication. These are your upper layers, and this is the specific port 1, 2, 3, 5, 6, 9. Suppose one wants to communicate to 9, so you add a service access point at which point of this receiver this packet is to be delivered. The transport layer adds an extra addressing, that is your service point access. We have discussed 2 duties. Now we are coming to the third one, that is reliable delivery. What do I mean by reliable delivery? That 4 aspects are concerned here. Error control, whether there is any error or not. Sequence control, that all the packets arrive in the same sequence. Loss control, if one of the packet has lost. And duplication control, if the packet received is a duplication of any other packet received, right? These four things will be taken care of in transport layer. If you remember, data link layer also provides you error control when we discuss error control and detection. But transport layer also provides you this. What is the difference between the two? We'll discuss now. Coming on this first aspect, that is error control. Error control means that whether there is an error or not, the packet sent by the sender is received the same by the receiver. Error control is also done in data link layer. Data link layer used to do error control node to nodes. What I mean by node, a computer is a node, a router is a node, these routers are a node, and this is a node. So this is a network. These computers are joined by these two routers. Error control dealt in data link layer was concerned node to node, from this computer to this. That means till start and the end of the transmission was only dealt in data link layer. From router to router, this error check was done. Matlab while traveling in transmission, any error occurred or not was dealt in data link layer. But if some error occurred while processing of the information in these nodes, this was not checked in data link layer. And the error checked in transport layer is end to end. That means from first computer to the next. If some error occurred meanwhile while processing, that is also being corrected in transport layer, which was not being corrected in data link layer. Coming on the next aspect, that is sequence control. What you are doing here in sequence control is, if your message is very large, the message is divided into smaller packets, and so that the lower layers, data link layer and network layer, can handle that packet. So what you are doing here is, if the message is very large, you do segmentation. If the message is very small, you can concatenate the smaller message into big messages. This is concatenation. So with each and every packet, we attach a sequence number at the end of the segment. This sequence number is attached via transport layer. Suppose this thing will get clear by this example. We are taking an example of a banking scenario. What is happening here is that a customer A, this is first customer, this is your second customer, these are various paths through which the message can be transferred. These are the routers which are connecting these computers, right? What you have to do is, first transaction you have to make in which you are transferring $5,000 from your checking account to your saving account. Then you are transferring that $5,000 to John. Now suppose this packet 1 is being transferred with this path, and this packet 2 transfers from this path. But we received them out of sequence, or the packet 1 was not arrived, only packet 2 was arrived. So what happens if there is no balance in the saving account? So John, the 5,000 cannot be transferred to John. So the sequence control is very important, that the packet should be reordered at the receiver. So sequence control is controlled by transport layer. Next comes your loss control. What do I mean by loss control? If one of the packet misplaced, right? Let's take the previous example again. If there are packet 1, 2, 3 to be sent, if 2 gets lost in some, while transferring, you receive only 1 and 3. So this is a problem in banking scenario. This makes a major problem. So you have to control the loss control. This can be also dealt with sequence numbers at the receiver end. When you will be rearranging your packets, you see that 1 is there, 3 is there, but sequence number 2 is missing. So you get to know that the packet is lost. The receiver can request the sender to resend it. Next comes duplication control. Duplication control means sequence numbers suppose a packet is being received twice. So you get to know while arranging that this is a duplicate and you discard it, right? Suppose you have a packet saying transfer $5,000, but you receive it twice, so that doesn't mean that you will in total transfer 10,000. You will get to know that it is the packet with the same sequence number, so you will discard it. Now the last responsibility comes as flow control. Flow control in transport layer is very much similar to the flow control as it was there in data link layer. In data link layer we did flow control. I hope you all remember what is flow control. Flow control is that the sending speed is so fast that it overwhelms the receiver and receiver cannot process it and the packets get lost at the receiver end. Therefore we apply the mechanism of flow control. We did their flow control sliding window. The same sliding window protocol is implemented in transport layer also. In the sliding window protocol, there was a window size. The window size is variable here. It can keep on changing. How it works, it is very much similar to the data link layer. As you can see here in this diagram, what we are doing is, these are your frames. But the major change is it is not frame oriented here, it is byte oriented. Byte by byte these are made. This is your window size from 6 to 14. That means these 5 bytes are being sent and acknowledged. This side moves whenever an acknowledgement is received. This side moves whenever a packet is sent. In this way you can adjust your window. This is very much similar to our previous. Next responsibility of transport layer comes as multiplexing. What is multiplexing? You are combining various signals together to make it a composite signal which can be sent together in a single link. So there are two types of multiplexing done here, upward and downward. What do you mean by upward? That transport layer, various transport layer connections are combined together, and then in network layer you are using one virtual circuit. That means small transport layer connections are combined into one network layer connection so that only one network is being used. Downward means small network, one transport layer connection uses multiple. There was only one transport layer connection, but it is huge enough and you use 3 virtual circuits here. So this was your downward multiplexing. These were the duties of transport layer. The last topic here in the transport layer, we will be discussing connection. As discussed earlier, the connection made between two devices can be connection oriented or connection less. Generally we use connection oriented, and this is done in there are 3 stages to make any connection. The first stage is connection establishment, data transfer. You first establish a connection, then you transfer the data, and then you terminate the connection. The connection establishment is a 3-way handshake. What do we mean by 3-way handshake? जिसको पहले connection बनाना है वो request भेजेगा, जिससे वो request भेज रहा है, responder returns the confirmation, yes I am ready to make a connection. Then the requesting computer, जिसको request करा था, जिसने connection, returns a packet sending an acknowledgement of the confirmation कि मुझे तुम्हारी confirmation मिल गई है for the request. This is shown here in the diagram. The requesting computer sends a connection request, the responding computer sends the connection confirmation, and this sends the acknowledgement, right? जब connection बन जाता है, you transfer the data. After transferring the data, last में there is connection termination. What is there in the connection termination? It's again a 3-way handshake process. जिसको कनेक्शन डिस्कनेक्ट करना है वो पहले रिक्वेस्ट भेजेगा डिस्कनेक्ट करने की, आप उसे कंफर्मेशन दोगे, देन यू विल सेंड द एक्नॉलेजमेंट ऑफ द कंफर्मेशन. So here we have completed with the transport layer. In the next class we will be starting with the session layer. Thank you.